In this problem, we want to find the consumer surplus for this demand function, given that the equilibrium price of a unit is $100. So what we are not given that we also need is the equilibrium quantity for that upper limit of integration right there. But we can find that by plugging in price for the demand function. So d of x on a demand function actually equals price. So this means that d of x is 100, that's that 100 right there, equals 1300 minus 3x squared, and that is the equilibrium quantity because I'm plugging in the equilibrium price right there for d of x, okay? Because d of x, the demand, where x is the input, gives you price. So we can solve this for the equilibrium quantity. If we subtract 1300 from both sides, we get negative 1200 equals negative 3. So it's the equilibrium quantity squared. Divide both sides by negative 3. 1200 divided by 3 is 400. So we get 400 equals the equilibrium quantity squared. So square root of 400 is 20. So the equilibrium quantity is 20. Okay, so for our integral, we're going to integrate from 0 to 20. The demand function, 1300 minus 3x squared minus the equilibrium price is minus 100 dx. Now we can integrate like this, but I'm going to go ahead and simplify the integrand first by subtracting 100 from 1300 to get the integral from 0 to 20 of 1200 minus 3x squared dx. So this is 1200x, and then the integral of x squared is a third x cubed. Okay, so we have minus 3 times 1/3 x cubed, and we're going to evaluate this from 0 to 20. Of course, the 1/3 and the 3 cancel. So we have, plugging in 20, we have 1200 times 20 minus 20 cubed. And then minus, when we plug in 0, we will get 0. So we'll need a calculator here. See, so 1200 times 20 minus 20 cubed is 16,000. So the consumer surplus is $16,000.